Hello and welcome to my FI3183 presentation for my third milestone where perhaps we all will rise as the champions of the world. I am the sole representative of Light.Bright and my main agenda here is to utilize CViT to detect deepfakes from various deepfake generation techniques. Let me give you a brief introduction to CViT or Convolutional Vision Transformer. It is made by Teresa Wodajo of GMA University and Solomon Adnafu of Addis Ababa University. It consists of two main elements, which are the CNN and the VIT. The CNN, or the Convolutional Neural Network for short, it extracts the learnable features from the image, and the CViT will take the feature as its own input to be able to categorize the item to be real or fake. It is heavily trained on the deepfake detection challenge dataset, which consists of real videos and deepfakes of human faces. This is an image consisting of CViT's mechanism, where it has the CNN part and the CViT and the VIT part. What are the actions I've taken here? I've adapted CViT for use in Google Colab, as if unchanged, it will cause the Colab session to crash. I've also attempted to train my own model. However, doing so causes the predictions to go totally to whack, as these prediction labels should not be dissimilar. I decided to utilize pre-trained weights since I cannot train my own model, and those weights will be utilized against certain deepfake generation tactics, where I'll create deepfakes from those tactics and then I'll plug those deepfakes to CViT and see what happens as a result. My first test is against motion supervised co-segmentation, which in short is a self-supervised deep learning method which is able to obtain segments that correspond to parts of an object, which allows for facial or feature swaps. For example, you can swap out the beard, the hair, the lips, among other things. To give a rundown on the label, if the label is more than or equals to 0.5, it is classified as a fake video. If the label is less than 0.5, it is classified as a real video. So, all of the fake videos, 6 out of 9 are correctly identified, and all of the real videos, 2 out of 5 are correctly identified. We have an overall accuracy with these samples as 57%. Except for lip swap, all the videos have more confidence that the fake videos are fake if they have a real video to compare to. For example, Taylor Obama real has a value of 0.293. However, Taylor Obama fake has a less degree of being real by having its label being 0.33. It has more confidence of being fake than Taylor Obama real. Next up, my test is on FSGAN, or Face Swapping Generative Adversarial Network. It is a subject-agnostic deep learning-based approach to perform face swapping and image video reenactments. Out of my tainted videos, 3 out of 5 are correctly identified, and out of the real videos here, 6 out of 8 are correctly identified. These samples create an overall accuracy of 69%. Once again, just like the previous example, we have more false video confidence on the false examples than the real examples used, except for the Putin Trump output. For example, my video on Charles Leclerc creates a label of 0.193. Max Verstappen creates a label of 0.537. Putting Charles' face on Max Verstappen creates a label of 0.610, which creates it to be categorized as fake. My final attempt was to perturb the deepfake videos with fast gradient sign method, or FGSM. Applying FGSM on every frame of a deepfake video, and I decided to take previously used videos to compare the predicted values before and after perturbation. With these results, outside of beard swap, other examples used have their fake video confidence actually increased. The perturbed values, except for beard swap, are actually higher than unperturbed, which means those videos are more likely to be detected as fake. What does all this tell? The conclusions that can be drawn here is that for CViT, FGSM perturbations may not slip under its radar. It may even do the opposite. It may even make videos be more likely to be detected as fake. With CViT, false positives and false negatives happen a lot, regardless of the deepfake generation technique used, and regardless if the video is real or not in the first place. CViT also seems to create a generally higher fake confidence on videos that are actually tempered compared to videos that are real, mostly. And despite the flaws it has in detecting deepfakes, we still get a slightly more than half accuracy overall for real and fake videos. Sadly, that's all I have to show to you. Thank you so much for listening. I'd like to point you out to several resources, including the papers I've taken from, and the links to several Google Colabs and resources I've used. I'd like to give a special shout out to Duck.Toothless and Duck.BecauseLike_Attract_Bugs for their implementations on FGSM and FSGun respectively. Without their implementations, without their work, I wouldn't be able to use CViT against those methods to see how CViT fares. Do take note that their Google Colabs are actually my own copy of their Google Colabs, and because the copies are made at a certain point of time, it may differ greatly from their actual up-to-date versions if you are in the loop. I'll also like to point you to the direction of my own Google Colab, which has the CViT deepfake detection setup. It allows you a guided experience to try CViT for yourself. You can put your own files and see what CViT thinks of them. Other than that, I don't really have anything else to present. I am done here, and I hope you have a nice rest of your day. I hope you have a nice time in the future. Thank you so much for lending your ear and time.